On the night of November 27, something happened that had never quite happened this way before. There were no sirens, no breaking news banners, no urgent countdowns. Instead, in silence, the United Nations activated the biggest planetary defense test humanity has ever attempted. Not in a computer model, not in a tabletop exercise. For the first time, a real global drill was launched around a real interstellar object, a comet called 3I Atlas. You clicked on this video because that title touched a very specific part of your mind. Part of you wants to know, almost clinically, what biggest planetary defense test ever actually means. Another part of you, the part that has been following 3I Atlas for months, wants to understand why this visitor from beyond the solar system was important enough to bring the UN into the story. And beneath all of that, there is a quieter wish to hear the full picture in one calm, clear, unhurried place, to understand what happened without feeling like you are being pushed into fear. So let's start with the reason this night mattered. For 29 days, 3I Atlas disappeared behind the sun, lost in the glare where no telescope on Earth could safely track it. Astronomers knew it would come back into view, but they did not know exactly how its activity, its jets of gas and dust, might nudge its path while it was hidden. When it finally emerged again, the timing was perfect for something the planetary defense community had wanted for years. A rehearsal using a live interstellar target. That is what the United Nations authorized. A 2-month-long campaign from November 27th through January 27th, asking observatories around the world and spacecraft around Mars to track one faint ancient comet with as much precision as possible. The goal was not to save Earth from 3I Atlas. The goal was to learn how well we can see, measure, and agree about the path of a stranger from another star. You have seen how this usually goes. A strange object appears. Headlines split between curiosity and alarm. Some voices insist that nothing is wrong. Others hint that everything is. In the middle, you are left with scattered facts and a mind that still does not feel settled. Tonight's story is here to do something different. It will walk you, step by step, through what actually happened when the UN said yes to this drill, and why the people who study threats from space were excited rather than afraid. You will hear how data from orbiters around Mars sharpened our knowledge of 3I Atlas by an order of magnitude. You will hear why a single blurry image from the HiRISE camera caused quiet debate inside science teams, and why they ultimately treated it as an odd but harmless artifact. You will learn what it means to run a global drill when the object you are tracking is older than your sun, older than your planets, older than our entire species. Most importantly, you will never be asked to panic. This is not that kind of story. The comet is not on a collision course. The drill is not a reaction to secret danger. In fact, the reason this campaign could be so open, so coordinated, is because 3I Atlas is safely distant. That safe distance gave humanity a rare gift, a chance to practice calmly, to test our systems without the clock ticking down. So you lie back and let your mind drift, listening to an unpacking of one of the most unusual nights in modern astronomy. A night when telescopes in Arizona, Chile, Hawaii, the Canary Islands, South Africa, and Australia all turn toward the same moving point of light, A night when orbiters around Mars joined in, giving a second vantage point from another world. A night when, without fanfare, humanity proved that it can coordinate across continents, agencies, and orbits when the sky presents a question. Tonight, you will get a clear path through the noise. You will hear how 3I Atlas was found, how its interstellar nature was confirmed, and how its reappearance from behind the sun became the trigger for the largest planetary defense drill ever attempted. You will understand what the UN actually did, what scientists actually measured, and why, in the midst of all the unknowns, they kept repeating the same quiet reassurance. This one is fascinating, and this one is safe. In return for your attention, this story offers three simple things. First, it offers understanding, the kind that lets you file this event in your mind, not as a source of anxiety, but as a clear chapter in the history of how we watch the sky. Second, it offers perspective, a reminder that an object which has drifted between stars for billions of years can pass through our neighborhood without meaning us any harm at all. And third, it offers calm, the deep, steady kind that comes from knowing that someone is awake, measuring, checking, and learning while you rest. As this night unfolds, you will move through control rooms, deserts, mountaintops, and orbits, following 3I Atlas as it crosses our sky and passes beyond our concerns. For now, all you have to do is listen, breathe, and let the story of this quiet rehearsal settle around you. When you think of a comet, you probably picture something local, a leftover shard of our own solar system, looping around the sun on a stretched-out path and returning every few centuries like a familiar ghost. But 3I Atlas is nothing like that. It doesn't belong to our sun, our planets, or our history. It is a visitor from somewhere else in the galaxy, and the more you learn about it, the more it feels less like an object and more like a character the universe has been writing for an unimaginably long time. You first meet this traveler on July 1st, 2025, in the high, dry air of Chile. One of the Atlas survey telescopes is quietly scanning the sky for anything that moves. On that night, a faint streak appears where nothing should be. At first, it's just another dot to catalog. But when astronomers run the orbit, something snaps into focus. The path is wrong for a solar system native. The line traced through space is not a loop. It does not bend back toward the sun. It opens outward, like an arrow already loosed. The orbit is hyperbolic, with an eccentricity of about 6.139, far beyond the values you see for comets bound to our star. Its speed is enormous, roughly 250,000 kilometers per hour. These are the fingerprints of an interstellar origin. This is the third confirmed visitor from another star system. That is why it receives its name, 3I, for Third Interstellar. From that moment on, 3I Atlas is not just a dot in the data. It is a story in motion. Astronomers trace its path backward and forward in time. Backward, into the deep dark between the stars, where its journey began long before Earth existed. Forward, past the sun, past Earth's orbit, and outward again into interstellar space. It swings by our star only once. There are no second chances with a traveler like this. You picture it in your mind, a nucleus, perhaps a few hundred meters to a few kilometers wide, made of frozen material older than your entire planet. As it approaches the sun, a coma blooms around it, a thin, glowing atmosphere of vapor and dust. Behind it, a tail stretches out, pushed by sunlight and the solar wind. Through a telescope, it is not dramatic, not the kind of comet that fills the whole sky. It is a soft, bluish haze, like the quiet breath of a very old star. Its age is one of the most striking things about it. The best estimates place the material in 3I Atlas somewhere between 7.6 and 14 billion years old. Even the low end of that range makes it older than Earth. The high end hints at something even stranger, that some of its atoms may have condensed when the universe itself was young, before the Milky Way had fully grown its spiral arms. The dust locked in its ice may have been forged in a supernova that flared and died long before our sun was born. If you let that sink in, you begin to see 3 Atlas differently. It is not just frozen rock and ice. It is a moving archive, a physical memory of other suns and other skies. It may have formed in the outskirts of a young star system, been flung outward by a violent encounter, and then spent billions of years drifting through interstellar space, passing quietly through regions your telescopes will never map. Along the way, it may have skimmed the edges of systems with warm worlds and clouds. It may have crossed regions that once hosted life, or that might host life one day. No one can say for sure. But when you think about how long it has been in motion and how far it has likely traveled, you feel as if you are watching a messenger from a chain of histories far beyond your own. You can't help but wonder if someone else, around some distant star, had the tools you have now. Would they have watched the same comet drift past their sky ages ago? Did they give it a name? Did they point instruments at it, curious about the stories trapped in its ice? Or has 3I Atlas wandered mostly unnoticed, waiting until now, until this brief crossing of our orbit, before anyone finally paid attention? There is another detail that lingers. This comet happens to pass our neighborhood at a time when humanity can actually see it. A few hundred years ago, it would have slipped by unheard. A few hundred years from now, who knows who will be here to look up? But right now, in these few months, you live in an age with survey telescopes, space observatories, orbiters around Mars, and a planetary defense network capable of organizing a global drill. For once, the universe has sent a visitor at a moment when we are able to greet it. That timing quietly elevates 3I Atlas from curiosity to opportunity. In physical terms, it is harmless. It swept past the sun on October 29th. It passes safely by Earth on December 19th, tens of millions of kilometers away. Its path is clear. It will not hit anything important. But in terms of training, of practice, of asking how well we can watch the sky in real time, it is almost perfect. That is why scientists talk about 3I Atlas with such respect. Comets from our own Oort cloud are fascinating. Interstellar comets are rare. They are, as one NASA planetary defense expert put it, natural gifts for testing our tracking abilities. They move fast, they come from unknown backgrounds, and then they are gone. You do not get many chances like this in a single lifetime. So as you listen, you are not just hearing facts about a distant object. You are meeting a traveler that has been in motion since long before your sun lit up the sky. It has seen things no telescope will ever see. It has crossed regions of space your species has never mapped. And for a brief moment, this moment, it passes close enough for your instruments to follow it. Carl Sagan once said, "We are the local embodiment of a cosmos grown to self-awareness." Lying here, letting your mind drift around this comet story, you become part of that awareness. You are one more mind on one small world, paying attention to an ancient stranger moving through the night. And that is what makes 3I Atlas so important to the story you are hearing tonight. It is harmless. It will not come close to Earth. Its path is clear and safe. Yet because it is interstellar, because it is rare, because it is passing by at exactly the moment when humanity can respond, it has become the perfect test case. The perfect chance to ask, how well can we see a visitor from another star? And how well can we work together when we do? So if the comet itself is harmless, why did the United Nations move so quickly? When you think about global action, your mind might jump to emergencies, alarms, urgent meetings, and fast decisions. But what happened on November 27th was almost the opposite. It was slow. It was steady. It was deliberately quiet. The United Nations stepped in, not because something was wrong, but because something was finally right. For once, humanity had the perfect conditions to practice watching the sky together. At the center of this effort is an organization most people rarely hear about, the International Asteroid Warning Network, or IAWN. It isn't an agency with a single headquarters or a single country behind it. Instead, it is a loose, collaborative network of more than 40 observatories, universities, and space agencies spread across Earth. NASA participates. ESA participates. JAXA, the Canadian Space Agency, South Africa's observatories, India's research institutions, they all contribute pieces of the puzzle. And above them, coordinating gently and quietly, sits the United Nations Office for Outer Space Affairs, or UNOOSA. IAWN is like a global listening system, built not from satellites or radars, but from minds. It is the place where data, techniques, predictions, and observations are shared long before public headlines ever appear. And when an interstellar comet like 3I Atlas comes into view, IAWN becomes the heartbeat of the world's sky-watching community. The dates chosen for the drill, November 27th, 2025 through January 27th, 2026, were not random. They were selected because of something simple but scientifically crucial: visibility. For 29 days, 3I Atlas was hidden behind the sun, invisible to all ground-based telescopes. Once it emerged from the solar glare, a narrow window opened. A window during which Earth-based instruments could see it, and Mars-based orbiters could see it from the other side. This alignment is rare. It gives science teams the chance to perform something called interplanetary triangulation, using two planets as vantage points to track a single object. It is one of the most precise methods humanity has, but it only works when the geometry of the solar system cooperates. With 3I Atlas, the timing was perfect. The comet appeared at just the right angle, just the right phase, and just the right brightness. A few months earlier or later, the geometry wouldn't have worked. For the first time, the Trace Gas Orbiter, TGO, and the Mars Reconnaissance Orbiter, MRO, could provide measurements that sharpened predictions from Earth by almost an order of magnitude. You can imagine it as switching from one eye open to both eyes open. Instead of seeing a single line of sight, you now see depth. You see shape. You see motion with clarity you didn't have before. This is what the UN meant when it announced a planetary defense drill. Not missiles, not impactors, not lasers pointed into space. The drill was nothing dramatic. It was simply the world checking how well it could observe, calculate, update, and cooperate in real time. It was a rehearsal of attention, of communication, of understanding how quickly scientists could refine what they know when a fast-moving object crosses the inner solar system. Think of it like checking the batteries in a flashlight before a storm. You don't check the light because the storm is here. You check it because one day, maybe far in the future, you might need it. And you would rather test it during a calm night than during a crisis. As you listen, picture the human side of this effort. Picture scientists in Arizona and Chile adjusting telescope schedules while colleagues in South Africa and India monitored the same patch of sky before dawn. Picture teams at ESA uploading commands to spacecraft orbiting Mars, while researchers in Japan analyze how jets from the comet might affect its path. Picture long email threads across 8 time zones, quiet Slack channels with graphs updating every 15 minutes, and early morning video calls where people compare their data over coffee. None of this is political in the dramatic sense. It is simply humans doing what humans do best when curiosity is shared and pressure is calm. This wasn't a scramble. It was a rehearsal of cooperation, a test of patience, precision, and communication. A moment when people around the world chose to align their instruments and their attention toward the same ancient traveler. If you think about it, these moments are rare. Countries often disagree. Agencies have their own priorities. Budgets shift. Missions change. But on nights like November 27th, the world pauses and looks in the same direction. For a few weeks, Earth becomes a single observatory, a single set of eyes, and it's hard not to feel some quiet pride in that. Not political pride, human pride. The kind that comes from knowing that your species can work together when it chooses to. That your world is capable of coordination, even without urgency. That curiosity is still one of the strongest forces we share. There's a simple sentence that scientists repeated throughout the campaign. It's a drill, but with real data from a real interstellar object. And there is something beautiful in that idea. A practice run that uses truth, not simulation, not make-believe. Truth from a comet older than your sun. This is where the philosophy enters. To prepare is not to fear. It is to respect the universe. It is to acknowledge that the cosmos is vast and full of motion, and that watching that motion carefully is a way of being responsible, not anxious. Preparation is calm. Preparation is wisdom. Preparation is the opposite of panic. All of this sets the stage for something else, something you will hear in the next part of the story. Because while the drill itself was peaceful, something unexpected happened in the middle of it. Something small, subtle, and deeply intriguing. And the moment it happened, every team participating in the campaign paused. That moment did not cause panic. It did not cause alarm, but it raised a question. And questions, especially gentle ones, are the starting point of every discovery. So how do you run the biggest planetary defense test ever without alarming the world? A planetary defense drill sounds dramatic when you first hear the words. Your mind might jump to impossible scenes, rockets, sirens, countdowns, last-minute heroics. But in the real world, a drill like this one is nothing like that. It is quieter, more deliberate, almost meditative. It is built on small actions repeated over and over again, each one deepening our understanding of how the universe moves. And with 3i Atlas drifting calmly across the sky, humanity finally had the perfect chance to practice. The drill itself follows 5 simple steps, simple in theory, but profound in execution. The first step is detection. Someone, somewhere, has to notice the object. It might be a large survey telescope in Chile, or a smaller observatory in Hawaii, or even a citizen science camera in the Australian desert. In the case of 3i Atlas, the detection came from the Atlas survey on July 1st, 2025. From that moment, the object becomes a shared responsibility. The second step is global follow-up. Once astronomers identify something interesting, eyes around the world turn toward it. Telescopes in Europe, North America, Asia, Africa, and South America all take turns watching the same patch of sky as the Earth rotates. They capture images, spectral lines, brightness variations. Every observatory becomes one piece of a global mosaic. The third step is triangulation, using multiple worlds, if possible, to see the same object from different positions. This is where 3i Atlas became extraordinary. Because orbiters around Mars were positioned perfectly, they could watch the comet from a different angle entirely. From Earth, we saw it moving against a backdrop of stars. From Mars, its motion had a different signature. Combining these 2 vantage points is like opening a second eye, allowing depth to emerge. The fourth step is prediction and refinement. Every new measurement sharpens the object's orbit. Every updated trajectory improves the certainty of where it will go. With fast-moving interstellar comets, small changes matter. A jet of vapor on one side can shift its path more than you might expect. So the world's scientists measure, update, recalculate, and correct. Gently, methodically, hour by hour. And the fifth step is evaluation. The drill examines how well everyone worked together, how quickly data traveled, how accurately orbit models aligned, how smoothly teams coordinated across languages, time zones, clouds, storms, and instrument schedules. It is less about the object itself and more about the people who tracked it. This is the backbone of the drill. But to understand why it felt meaningful, you have to imagine the backdrop, the quiet, continuous flow of information that never truly stops. Picture a late November night in the Canary Islands. A small team finishes a 3-hour block of observations, uploads the frames, and sends a short note to the international network. Coma brightening stable. No unusual jets detected. At almost the same moment, midday in Japan, a different team analyzes the same data, comparing it to infrared readings from a ground-based telescope near Nagano. Meanwhile, the Hubble Space Telescope schedule shifts slightly, opening a window to capture ultraviolet data that wasn't possible earlier in the month. Then there is JWST. Even with its packed calendar of galaxy surveys and exoplanet atmospheres, the teams carve out a sliver of time to collect spectroscopic signatures from 3i Atlas. not because the comet is dangerous, but because it is rare. Its composition is a message from before your sun was born, and a drill using a real interstellar object deserves real measurements. Citizen scientists join in too. Amateur astronomers send in optical frames taken from suburban backyards and rural fields. Their data isn't as sharp as the professional observatories, but in a drill like this, every measurement helps. Each image becomes one more point on a graph, one more check against the predictions, one more way to refine the orbit. All of this creates a rhythm, a slow, steady pulse across the globe. You might even call it a scientific meditation. Every hour brings another update, another measurement, another breath of the comet, another refinement in the model. In this rhythm, nothing is rushed, nothing is frantic. Humanity is simply learning how to listen to the sky more carefully. And yet, there is a mystery in the background. Not a frightening one, but a gentle question that keeps resurfacing. Why are Mars-based observations so important? Why does the UN emphasize this? Why do the teams care so much about reducing data delay to just a few minutes? The answer lies in speed. Interstellar objects move differently from local comets. They come in fast. They leave fast. And when you have only one chance to observe them, every bit of precision matters. A measurement from Mars fills in the blanks left by Earth's geometry. It helps correct for the subtle pushes and pulls on the comet. It shows whether jets on the sunlit side are nudging it one way or another. It turns a guess into a calculation, and a calculation into something closer to truth. This is why 3I Atlas was the perfect test comet. It posed no threat. It stayed bright as it passed the sun. Its orbit was clear, steady, predictable. It moved into a position where Earth and Mars could both see it. It offered a once-in-a-generation chance to test how fast, how precisely, and how cooperatively humanity could track a visitor from another star. As you listen, imagine the room inside ESA's Operations Center where someone finally said the words, "You cannot script this. The comet writes the drill for us." That is the feeling that spread through the network. Not fear, not urgency, just a sense of respect for the rare alignment of timing, geometry, technology, and luck. From Arizona to Cape Town, from Canberra to Chile, the world was practicing something simple and profound: attention, learning to look up together, learning how to respond not to danger, but to opportunity. The drill was a way of honoring the universe's complexity, of acknowledging that even harmless objects deserve to be understood with care. And then, in the middle of this peaceful rehearsal, something subtle happened. Not alarming, not disruptive, just unexpected. On November 19th, before the full drill even began, the Trace Gas Orbiter around Mars captured a single frame, one piece of data that did not fit perfectly with the rest. It wasn't a crisis. It wasn't a warning. But it was enough to make every team pause, lean in, and look a little more closely. And then, on November 19th, Mars saw something unexpected. High above Mars, where the thin atmosphere fades into the deep velvet of space, the Mars Reconnaissance Orbiter circles quietly. On board, the HiRISE camera does what it always does. It takes impossibly detailed images of the Martian surface, of dust devils, of crater walls, of ancient riverbeds. But on November 19th, it pointed not at Mars, but out into space, toward a faint, moving speck. 3. Atlas. It wasn't a special session. It wasn't a dramatic request. It was part of a scheduled series of calibration images, routine snapshots meant to support the upcoming planetary defense drill. HiRISE took several frames in rapid succession, each one tracking the comet's tiny motion against the star field. Most of the frames looked exactly as expected. A soft coma, a faint tail, a dot barely brighter than background noise. But one frame, just one, made the data processing team pause. Not gasp, not panic, just pause. You can imagine the scene. A softly lit room, monitors showing small grainy images, a few analysts sipping coffee, and then one of them notices something. Can you look at 44C? Something's odd. The anomaly was subtle, nothing dramatic, nothing that suggested danger or intelligence or any kind of intent, just something strange enough to break the rhythm of routine. In that single frame, a thin streak of light extended farther than expected, a stretched glow that didn't match the pattern of the frames before or after. Beside the coma, on the comet's sunlit side, a tiny dot appeared, almost like a second spark. It could have been noise. It could have been sensor scatter. It could have been a cosmic ray clipping the detector. But it wasn't an obvious one. And across the tail, faint as a pencil line drawn by a hesitant hand, there was a diagonal streak, not quite matching the angle of typical cosmic ray hits, not quite matching the motion blur you'd expect from a fast object. It was just off enough to make people wonder. Inside the analysis group, two quiet camps formed almost immediately. The conservative group, the ones who had seen thousands of images like this, shrugged gently. Artifact, noise, cosmic rays, motion blur. HiRISE is powerful, but it is not immune to physics. The curious group leaned forward a little more. The geometry looks too symmetrical, one said. The angle doesn't match a typical cosmic ray strike, another noted. We need more frames before ruling anything out. Not disagreement, not conflict, just a difference in instinct. One side leaning toward the ordinary explanation, the other side acknowledging that sometimes the universe slips something unexpected into a single pixel. NASA, to its credit, did something important. It spoke up quickly. To avoid speculation, NASA released the entire series of raw frames publicly, including the questionable one. The agency explained that the anomaly requires further analysis, but shows no sign of technological structure. Calm, clear, responsible. For a moment, you might wonder why something so small became a topic at all. But astronomy is full of illusions. Cameras in space are constantly struck by high-energy particles. Stars flicker, shadows shift. Instruments catch reflections, thermal noise, digital artifacts. Even the best telescopes have moments where single pixels behave strangely. So when you imagine that frame, imagine it not as a warning, but as an invitation. A little irregularity, a reminder that the universe is messy in beautiful ways. A reminder that science begins with noticing something that doesn't quite match your expectation. And this anomaly appeared in only one frame, just one. Not before, not after. The comet didn't change shape. The coma didn't flare. The tail didn't split. Nothing repeated. Nothing confirmed anything unusual. But scientists noticed something else, not in the pixels, but in the timing. Frame 44C, the only odd one, arrived 4 minutes later than the others. Not a long delay. Not suspicious. Just noticeable. Enough to make someone raise an eyebrow and say, "Huh, that's interesting." And that's all it was. Interesting. Nothing dangerous, nothing threatening, nothing that changed the drill, just something worth a second look. In fact, as one HiRISE engineer put it, it's almost certainly noise, but interesting noise. Another planetary scientist explained it even more gently. In astronomy, ambiguity is a feature, not a bug. Those words tell you everything. Science rarely deals in absolutes. It deals in patterns, probabilities, possibilities. Sometimes an image is perfectly clear. Sometimes it whispers instead of speaking. As you lie here listening, your mind drifts through that single imperfect frame. The faint streak, the tiny dot, the soft line across the tail. Your imagination fills in the shapes the way anyone's would when staring at a picture taken light years from familiar ground. Curiosity grows, but calmly, slowly, with room to breathe. Because the story isn't about fear. It's about the delicate balance between certainty and mystery that makes astronomy so human. Some things we know, some things we don't. And somewhere in between is a single frame from Mars that made people look twice. But the real surprise wasn't the image. It was how the world reacted to it. When the HiRISE frame from Mars was released, the reaction wasn't panic. It wasn't disbelief. It wasn't even controversy in the loud sense of the word. It was something quieter, gentler, more human. People around the world simply paid attention in their own ways, for their own reasons. And for a brief moment, billions of us shared the same direction of thought, upward. Some people stared at the anomaly with childlike excitement, refreshing the raw data again and again, zooming in, zooming out, arguing pleasantly on astronomy forums about cosmic rays and sensor scatter. Others, the skeptics, leaned back with folded arms and raised eyebrows, not convinced, but not dismissive either. Just curious enough to follow along. And then there were the people who clicked on videos like this one, not for the data, not for the debate, but because the universe calms them. They didn't want a breaking news alert. They wanted a voice to tell the story slowly, gently, in a way they could drift with. Different moods, different hearts, different habits, yet all of them looking toward the same small visitor, moving beyond the orbit of Mars. That's the quiet beauty of moments like this. Even when the reactions differ, the direction is shared. The world isn't arguing. It isn't choosing sides. It isn't trying to win. It is simply watching, together. In the desert air of Arizona, amateur astronomers stepped out into the cold night, adjusting homemade mounts, taking short video clips of the tail as it elongated day by day. On the other side of the world, a small observatory in Japan pointed its telescope upward and streamed the dim glow of 3I Atlas live to a handful of night owls. Europe lit up too. ESA's webcast switched on its cooling blue studio lights as experts answered gentle questions from the public. In India, a group of university students gathered around an old, slightly scratched pair of binoculars on a rooftop, passing them around and whispering in excitement every time the faint smudge came into view. In South Africa, a radio array quietly collected signals from the dust jets, tiny fluctuations in frequency that would help refine the comet's outgassing pattern. 6 continents, a dozen languages, thousands of eyes, one visitor from another star system. And in all these places, for all these different viewers, the mood was the same: calm curiosity. Even the scientists, usually buried in calculations, paused to feel the moment, This wasn't just data. It wasn't just orbit refinement. It was a reminder that we all still live beneath the same ceiling of stars, even if we see it from different horizons. What made this night feel special wasn't urgency. It wasn't risk. It wasn't even the anomaly itself. It was the rare sensation that humanity was quietly aligned. Not politically, not culturally, but directionally. The telescopes all pointed outward. The attention pointed outward. The conversation pointed outward. As one astronomer at ESA said so simply, for once, every eye was pointed outward, not inward. And when people look outward together, something soft happens. The world stops feeling like a collection of borders and disagreements. It becomes a single world again. A small one, a fragile one, but a beautiful one too. It's important to say this clearly. NASA, ESA, JAXA, ISRO, CSA, SANSA, and dozens of others were involved in the tracking of 3I Atlas. But not in the heavy-handed political way people imagine when they hear the words international coordination. This wasn't about power. It wasn't about authority. It wasn't about who leads or who follows. It was simply about sharing the sky. Everyone contributes a sliver of precision. Everyone sees a part that someone else can't. No agency owns the view. And perhaps that is why interstellar objects feel different. When something from beyond the solar system enters our neighborhood, it doesn't belong to a nation. It doesn't belong to a hemisphere. It belongs to the whole of us equally. It becomes a mirror moment, an instant when the universe holds up a quiet reflection and lets humanity see the simple truth that we're all standing on the same small world, looking outward from the same shoreline of light. As you listen, you feel the wideness of that thought settle into you. You feel the gentle comfort of knowing the sky can still bring people together. You feel something even deeper too, something Sleepy Universe always brings out. The realization that when you look outward, you quietly learn inward. Because unity doesn't require agreement. It only requires direction. And yet, even unity leaves room for curiosity. Even in peaceful alignment, questions begin to bloom. Why did the UN choose this moment? Why this comet? Why now, when 3I Atlas is harmless and drifting safely away? No one was afraid, but many were curious, and curiosity in times like this spreads just as widely as wonder. As Earth watched from below and Mars watched from above, the world found itself in a rare configuration. Every continent participating, 2 planets observing, dozens of institutions aligning into one network. It was a kind of coordination that only happens when the universe hands us a shared opportunity. Earth, Mars, and every observatory in between linked together in a quiet, elegant web. A web strong enough to hold a moment of unity and delicate enough to let each question pass through it. But unity doesn't erase curiosity, and curiosity soon turned into questions. When the world first heard about the UN's planetary-defense drill around 3I Atlas, the reaction wasn't panic. It wasn't skepticism. It wasn't denial. What you saw instead was something far more human, far more universal. Curiosity. Gentle, restless curiosity. The kind that rises anytime something unfamiliar enters our collective field of view. Across news articles, live streams, social media threads, and late-night conversations, 2 questions appeared again and again. You could hear them whispered in coffee shops, written under headlines, even murmured in quiet corners of online astronomy forums. The first question was simple. If it's harmless, why conduct the biggest drill ever? The second followed naturally. What if it suddenly changes direction? Two questions, both understandable, both rooted not in fear of danger, but in fear of the unknown. Humans have always reacted this way to the cosmos. A solar eclipse, a passing comet, a meteor storm. Even when nothing is wrong, the simple fact of not knowing awakens something ancient inside us. Not panic, just an instinct that whispers, pay attention, just in case. And so the world paid attention. Some asked those questions calmly, others asked them anxiously, but almost everyone asked them. The truth, of course, is quiet and comforting. Scientists monitoring 3I Atlas saw no signs of danger, no unexpected outgassing, no strange rotation, no acceleration, no deviation from its predicted path. Nothing unusual at all, aside from the fact that it came from another star system. People didn't fear the comet. They feared the mystery around it. As you look closer, you can divide public reaction into three gentle, overlapping groups. Group A was amazed. They treated 3I Atlas the way people treat eclipses, meteor showers, or the first images from the James Webb Space Telescope. To them, this was a moment of wonder, an interstellar traveler passing through the solar system, a cosmic event that wouldn't happen again in their lifetime. They stayed up late, watching live streams, tracking brightness charts, even pointing small backyard telescopes toward a faint glow in the cold night sky. Group B was curious, but calm. They didn't watch every update, but they followed along. They read headlines. They checked in occasionally. They wanted to understand the science without drowning in it. These were the people who typed, "Okay, but seriously, what is going on with this comet?" in New York Times comment threads. They clicked into Reddit's HiRISE space discussions, where amateur astronomers posted side-by-side comparisons of the comet over several nights. They tuned into small astronomy YouTubers explaining orbital mechanics with hand-drawn diagrams. And then there was Group C, the speculative minds. They weren't fearful, but they were restless. They asked the big, what if questions. Questions that live halfway between imagination and caution. These were the users in Discord servers talking late into the night, asking whether interstellar comets often carry surprises, or whether the UN drill meant something more than training. Not alarmists, not doomsayers, just people wondering out loud the way humans always do when the sky gives them something new to think about. Across all these groups, the emotional thread was the same. Uncertainty, not fear, not dread, just the quiet ache of wanting answers. And that is where the philosophy emerges. Humans don't fear danger. They fear unexplained motion. As one psychologist in a science communication interview put it, people don't fear danger. They fear unexplained motion. There's something profound hidden in that idea. Something that resonates with anyone who has ever stared at the night sky and felt their breath catch just a little. The unknown isn't threatening. It's simply unresolved. And until it is resolved, the mind leans forward. But in the vast scale of the cosmos, fear is just a small ripple. Curiosity is the ocean. And for most people, curiosity won. So the public kept asking, why this comet? Why this drill? And why now? The answer, gently and calmly, is straightforward. The UN drill was training. nothing more. It wasn't a reaction to danger. It wasn't a precaution against catastrophe. It was a practice session designed to strengthen the world's ability to track and analyze fast-moving objects. And 3I Atlas was perfect for that role. A real object, real data, clear trajectory, zero risk. A test target, not a threat. As people listened to scientists explain these things, on news segments, in online Q&As, in live stream chats, you could almost feel their shoulders relax. Not because the universe had changed, but because understanding had replaced uncertainty. Because knowledge, once shared, becomes something people can hold. And that's the subtle payoff of this moment. Not spectacle, not drama, but connection. You feel like you are part of the explanation. Like someone is walking beside you, not ahead of you. Like the sky isn't a source of fear, but a mirror that reflects your own curiosity. The world asked the right questions, even if they came from the wrong fears. And the next part of this story answers those questions more deeply. So let's explain the motion, the true science of an interstellar comet. When people hear the phrase interstellar comet, they often imagine something dramatic or dangerous. But the truth is gentler, more poetic, and far more fascinating. These objects are strange, not because they threaten us, but because they come from places we have never seen, carrying stories we can barely decipher. And to understand why 3I Atlas behaves the way it does, and why scientists treat it with both caution and admiration, you have to look back at the two visitors that came before it. The first was Oumuamua, discovered in 2017. It didn't have a coma, it didn't have a tail, and it didn't behave like any comet we were familiar with. It was dim, tumbling, cigar-shaped or pancake-shaped depending on who you asked, and it left more questions than answers. The second was 2I Borisov in 2019, much more classical, with a visible coma and tail, behaving like a normal comet but coming from beyond the solar system. And now, 3I Atlas, brighter than Borisov when first observed, more stable than Oumuamua, a clear coma, a definite tail, and behavior that fits comfortably into the category of a genuine comet. In some ways, it is the easiest of the three to classify, and yet, in other ways, it is the most mysterious. To understand why, imagine trying to measure a moving candle flame from millions of miles away. That is what astrometry, tracking an object's exact position, feels like for comet scientists. Comets don't follow perfectly smooth paths. Their surfaces heat up, releasing gas and dust. Outgassing pushes them ever so slightly, like tiny thrusters firing unpredictably. Jets form on one side more than the other, creating asymmetry. Dust blows out in uneven plumes. All of these small effects shift their motion by tiny amounts that must be measured and accounted for. Now imagine that same candle flame coming from another star system entirely. Imagine having no history of how it behaved before it arrived. Imagine not knowing whether its surface is brittle, porous, smooth, fractured, or ancient beyond your models. That is what makes interstellar comets uniquely difficult to measure. For comets born in our solar system, scientists know their typical behavior. They know the composition of Oort cloud objects, the way water ice sublimates, how dust scatters, how jets accelerate. But with an interstellar comet, almost everything is unknown. Its thermal history, unknown. Its age? Somewhere between billions and tens of billions of years. Its chemical composition? Likely exotic, likely mixed with unfamiliar volatiles. Its reflective properties? Different from solar system comets. Its expected brightness curve? Impossible to predict. So even though 3I Atlas is well behaved and safe, it still carries an air of unpredictability. An unpredictability that invites careful measurement, not fear. And that is why scientists value this moment so deeply. The data coming in from Earth-based observatories has been rich, steady, and remarkably clean. Hubble's July observations suggested a nucleus size within a predictable range. JWST was scheduled for early December to capture detailed spectra. And the Mars orbiter data, collected at precise intervals, gave scientists their most accurate interstellar astrometry to date. The brightness curve showed no anomalies. The coma expanded normally. The jets behaved as expected. In every measurable way, 3I Atlas has been exactly what a comet from another star should be. But the wonder comes from remembering what those measurements actually represent. Every particle in the tail of 3I Atlas carries its own cosmic biography. A single dust grain could have belonged to a star system that died when Earth was still molten rock. A molecule of water vapor drifting behind the comet might once have orbited a star 400 light-years away. Some fragments may have formed in the explosive remains of a supernova, a star long gone, its memory preserved only in drifting grains of dust. And as you consider that, a thought rises. Everything in the universe is recycled. Stars die. Their debris becomes planets. Planets collide. Their fragments become comets. Comets break apart. Their dust seeds new clouds. When you watch a comet, you aren't watching a single object. You're watching the history of several worlds woven into one. That is why interstellar comets feel different. They are not just time capsules from the early solar system. They are messages from other eras, other environments, other corners of the galaxy. As one astrophysicist noted, interstellar comets are cosmic immigrants. They arrive carrying whatever stories they have collected along the way, written not in words, but in chemistry, motion, and ancient dust. And as you lie here listening, you can almost picture the journey of 3I Atlas, drifting for billions of years, passing through star nurseries, crossing cold, empty regions where no light shines, navigating the faint magnetic fields between spiral arms, and then, by coincidence or by cosmic rhythm, arriving in our sky at a time when humanity is able to study it. This comet doesn't bring fear. It brings perspective. It brings awe. It brings a kind of peace. Because when you follow its slow path, you begin to understand how much of the universe moves without urgency, without conflict, without anything but quiet persistence. Carl Sagan once said, "We are made of star stuff." And interstellar comets remind you of that truth. They are physical proof that the galaxy is woven together, that dust from ancient stars becomes dust in new worlds, and that everything that drifts through space carries the fingerprints of somewhere else. So, what makes interstellar comets strange? Not danger, not unpredictability, but origin. An origin so vast and ancient that it stretches your sense of time into something wider. And yet, even with all this knowledge, there are still questions we cannot answer. Not dramatic questions, not alarming ones, but simple, lingering questions that brush the edges of imagination. Questions about where the comet has been, what it passed, what forces shaped it, what whispers of ancient chemistry it carries. Questions that science can measure in pieces, but cannot fully close. And that is where the next chapter of this story gently begins, where science meets something softer, something more human. But science is only half the story. The other half lives in our imagination. There's a moment whenever something from another star system sweeps through our skies, when the human mind does something beautifully predictable. It wanders, it imagines, it leans gently toward the edge of possibility. You can almost feel it happening across millions of living rooms, bedrooms, and quiet backyards at night. That small, private voice whispering, "What if?" And that's okay. It's more than okay. It's human. Whenever an interstellar visitor appears, our imagination wakes up. Our rational mind stays present, yes, but something softer steps forward too. The part of us that grew up staring at night skies, wondering what else might be out there. So tonight, in this quiet part of the story, you're allowed to wonder. You're allowed to ask the questions that drift at the edges of possibility. The questions that aren't meant to cause fear, only to stretch the imagination. One of those questions is simple. Why did the International Asteroid Warning Network choose 3I Atlas for the biggest planetary defense test ever attempted? Yes, it was convenient. Yes, it was bright, easy to track, safe, predictable. But some people wonder if convenience was the only reason. Was there anything unusual in early data that made 3I Atlas the candidate for such a massive drill? Did someone notice something interesting that wasn't mentioned in the early briefings? Almost certainly not. But the question itself is harmless and worth asking. Another curiosity arises from the comet's trajectory. 3I Atlas passed through Jupiter's Hill sphere, the gravitational region where objects can, under rare circumstances, be captured. Its path crossed that zone in what some have called a perfect window, a corridor of possibility that seems almost poetic. Probably coincidence, probably luck, but still, beautifully timed. And that's the tone of this zone. Gentle speculation, not alarm. Then there is the image, the HiRISE frame from Mars on November 19th, frame 44C, the one with the small side glow near the coma, the faint streak across the tail that didn't quite match the angle of a typical cosmic ray, the brightening that didn't appear in any other frame before or after. Why only one frame? Why did the internal message, tagged "Needs Review," make its way into public discussion? And why, after that, did every official explanation arrive so quickly, so tidily, so unanimously aligned? Most likely because the anomaly was exactly what NASA said it was. Noise, artifact, coincidence. But the timing made the world tilt its head for just a moment. From here, our thoughts can branch into possibilities. Not conclusions, just shapes of ideas drifting like dust in a comet's tail. The first possibility is the most straightforward. 3I Atlas is fully natural. Everything odd is noise. Science remains unbothered. A comforting, elegant answer. The second possibility is softer. Perhaps there were details scientists weren't fully certain about yet. Not alarming details, just unknowns. And in that uncertainty, agencies lean toward the interpretation least likely to cause confusion. Not hiding information, simply avoiding speculation. And the third possibility, the one that gently wakes the imagination, a tiny chance, so small it may not even deserve the word chance, that 3I Atlas is more than a comet. A probe fragment, a structured shard, a messenger of some kind, not a threat, not a danger, just something crafted rather than formed, something designed rather than born. Not likely, but not impossible in the strictest sense of the universe. And when you allow yourself to entertain the idea, even briefly, you realize something profound. If an advanced civilization wanted to observe a young species like ours, quietly, without interference, sending a tiny object through our solar system would be one of the simplest methods. No drama, no arrival, no signatures, just a silent traveler passing through the places where we tend to look. If someone wanted to measure our awareness, our ability to notice motion, to track anomalies, to coordinate globally, this would be the perfect kind of object to use. Bright, harmless, fast, ancient, just unusual enough to provoke curiosity, and just ordinary enough to be dismissed. Again, this is imagination, not fear. Wonder, not warning. And yet, the idea lingers. What if a comet isn't only a relic of the past, but a message? What if interstellar comets are the universe's way of sending us reminders of how small and how connected we really are? When you step back and listen, the thought becomes less like a conspiracy and more like a quiet philosophy. If any civilization wanted to send something across the galaxy without alarming anyone, a comet would be a natural choice. Organic, innocent, unremarkable on the surface. And perhaps that's why 3I Atlas feels different. Not because it is artificial, but because it reminds us how much of the universe we still don't understand. That's why officials have emphasized there is no techno-signature. That's why mainstream scientists categorize 3I Atlas as natural. That's why nothing in the data indicates anything engineered. And yet, you are allowed to keep a small corner of what if inside you. A gentle glow of possibility, a harmless thought, drifting quietly as you fall asleep. You don't need answers. You don't need certainty. You just need space to wonder. As Avi Loeb once said, when data is ambiguous, we must allow our imagination to participate, carefully. And Carl Sagan reminded us, extraordinary claims require extraordinary evidence. Tonight, you don't need extraordinary claims. You don't need extraordinary evidence. You only need the freedom to let these questions drift across your mind like cosmic dust. Whether natural or not, 3I Atlas forces us to confront a deeper question. What does it really mean to be prepared? Why do we feel better when we know someone is watching the sky for us? It's a simple question, but it reaches into a very old part of the human spirit. There is something reassuring about knowing that somewhere out there, even while you sleep, someone is awake, someone is alert, someone is tracing faint specks of light across a black canvas of stars. Not because danger is near, but because care is near. Preparedness has always been part of our story, but it isn't just a scientific protocol or a political mandate. It lives on 3 levels, 3 quiet layers that work together. The first layer is scientific. It's the telescopes that scan the skies every night. It's the satellites and radar arrays. It's the drills, the orbital simulations, the tracking networks that follow objects like 3I Atlas with gentle precision. This is the layer of data, of physics, mathematics, probability, and engineering. It is the part of preparedness that operates with numbers, but ultimately works on behalf of people. The second layer is social. It's the international coordination, the UN sessions, the IAWN collaborations, the agreements between nations that rarely agree on anything else. When countries share telescope time, when space agencies compress data together, when researchers pass observations across time zones in the middle of the night, that cooperation is its own kind of beauty. Preparedness at this layer is simply humanity practicing how to be one team. And then there is the third layer, the quiet one, the one no meeting agenda ever mentions, the personal layer, your layer. It's the calm that washes over you when you hear that scientists are tracking something bright in the sky. It's the reassurance you feel when you know someone is paying attention. It's the same comfort you get from scheduling a routine health check. You don't schedule it because you expect something to be wrong. You schedule it because checking gives you peace. Planetary defense works the same way. You don't prepare because the universe is hostile. You prepare because the world is precious. It's the cosmic version of caring for something you love. Preparedness is not fear. It is love extended into the future. Earth is small, just a pale blue dot floating in a sea of silence. But on this dot, life has gathered in improbable abundance. Children sleep. Oceans breathe. Cities shimmer at night. And somewhere, at any given moment, someone is looking up through a telescope, making sure this tiny dot remains safe. Meanwhile, 3I Atlas continues on its indifferent path, unchanged by our feelings or philosophies. It doesn't know our worries. It doesn't know our hope. It doesn't know it has become the centerpiece of a global drill. It simply moves as ancient ice has always moved, slowly, quietly, obeying the forces that shaped it long before humans existed. But even if the comet itself holds no intention, we do. We are the ones who choose to interpret its arrival as a moment to learn. We are the ones who use it as a prompt to test our instruments, refine our systems, and practice patience with the unknown. The drill around 3I Atlas is not really about the comet. It's about us. It's about whether we can work together when something unexpected enters our sky. It's about whether we can maintain clarity in the face of uncertainty. It's about whether our species, fragile, curious, beautifully imperfect, can prepare without panicking. Preparedness is a mirror. It reveals who we are more clearly than the comet ever could. And as you breathe slowly and listen, you might feel a quiet gratitude for the scientists who stayed awake through the night, for the observatories that never sleep, for the engineers who troubleshoot software at 3 a.m., for the agencies that share data across continents, for every person who chooses to look outward so others can rest inward. Because tonight, somewhere, someone is still watching the sky for you. And that single truth carries its own warmth. A warmth that settles in your chest. A warmth that feels almost like a soft hand on your shoulder. A reminder that you're part of a species learning to care for itself on a cosmic scale. And as that warmth grows, another gentle question arises. If we can prepare for interstellar visitors, what else can we prepare for? What kind of future could we build if we applied the same patience, cooperation, and care to everything we do? No alarms, no urgency, just calm reflection, an invitation to imagine what preparedness really means, not just for the planet, but for us as individuals. Because readiness is not a shield, It's a promise, a quiet promise we make to ourselves and to the generations who will come after. Preparedness is an act of care, not an act of fear. Or, as a UN official once phrased it, we're not doing this because of fear. We're doing this because we care about the only home we have. Carl Sagan said it too, in his own way. For small creatures such as we, the vastness is bearable only through love. And so, as the philosophers and poets reflected on these truths, the data kept coming in. When the UN's planetary defense drill officially began on November 27th, it marked the start of a 2-month window, a quiet global exercise stretching through January 27th, 2026. And as you're listening tonight, just 2 days after that launch, we find ourselves in a perfect moment, close enough to feel the freshness of new data, far enough to begin seeing the shape of the story. So let's gently close the loop. Let's look at what we know now. First, the core recap. The drill opened on schedule. The observatories activated. The global network synchronized. And 3i Atlas, the ancient visitor at the center of all this activity, continued along its pathway exactly as predicted. That alone is a quiet comfort. Trajectory matches every model built before perihelion. There have been no sudden changes, no strange accelerations, no deviations from the plotted arc. Its speed remains steady. Its brightness curve follows the same elegant decline expected of a comet moving away from the sun. Even its coma, glowing softly like a breath of ancient ice, has behaved with remarkable normalcy. The Mars data tells the same story. The Trace Gas Orbiter and the Mars Reconnaissance Orbiter have been sending back some of the most precise astrometric refinements ever collected for an interstellar comet. From their vantage points, separated from Earth by millions of miles, they provide angles we simply cannot achieve from home. Their combined measurements increased orbital precision tenfold. Errors shrank. Confidence levels rose, and the HiRISE anomaly, the faint lone feature in frame 44C, never repeated. Internal review labeled it a non-repeatable artifact, a phrase that in astronomy might as well mean it happened once, and that tells us everything we need to know. From Earth, the story is equally calm. More than 40 observatories have submitted astrometric data, each one helping weave a tighter net around the comet's path. Amateur telescopes added their light as well. Through projects like Interstellar and Zooniverse, citizen scientists provided measurements with quality comparable to official submissions. Under those thousands of eyes, the coma remained stable, slightly asymmetric, as most comets are, but comfortably within expected shapes. The dust tail behaved predictably. The jets pulsed with familiar rhythm. Nothing surprising, nothing worrying, nothing outside the boundary of natural behavior. Space telescopes joined in too. Hubble detected the fingerprints of water, carbon dioxide, dust, and hydroxyl, exactly the substances you'd expect from a comet born of frozen worlds. No unusual spectral lines, no unexplained emissions, no techno-signatures whispering from between the data points. JWST, scheduled for early December, is expected to add even more detail: temperatures, chemical ratios, isotopic clues about the comet's birth environment. But so far, everything aligns with a natural origin. And that is the mainstream scientific conclusion. 3i Atlas is a natural interstellar comet. ancient beyond comprehension, fascinating beyond description, and completely safe. A NASA PDCO scientist put it in the simplest possible terms. From a planetary defense perspective, this is our best kind of interstellar object. Fascinating and harmless. The more data arrives, the more that sentence holds true. And yet, even in the warmth of reassurance, one soft mystery remains. One that is scientific, not speculative. We know what 3I Atlas is made of. We know how it behaves. We know where it is going. But we still don't fully know where it began. Did it form around a young star that died billions of years ago? Did it drift through the spiral arms of a different galaxy before entering ours? Did it witness the births and deaths of worlds we'll never see? In cosmic terms, origin is always the hardest part of the story to find. And maybe that's why objects like 3I Atlas capture us so deeply. Because they remind us of something at once humbling and empowering. We are very good at predicting where things will go. But we are still learning how to understand where things come from. Tonight, you can take comfort in the certainty we do have. There is no hidden danger in the data. No shift. No threat. Just an ancient traveler passing through, giving humanity a rare chance to practice how we protect our tiny world. The numbers are comforting, but tonight, you don't have to think in numbers anymore. Somewhere far beyond the reach of city lights, past the warm halo of Earth's atmosphere, a faint traveler is drifting into deeper darkness. 3I Atlas, the interstellar visitor we followed tonight, is moving farther from the sun with every passing hour. Its long, pale tail stretches behind it, like a soft chalk line brushed across the night. The solar wind, once lively near perihelion, has quieted. There are no flares, no sudden bursts of heat, no surprises left to reveal. Just a cold, ancient object slipping gently outward, exactly as it has done for billions of years. Far below, some of the observatories that tracked it through the drill have already turned off their instruments for the night. Screens dim. Cooling fans click softly. Doors are locked behind tired researchers heading home under starlight. A few sentinel telescopes remain active, silent guardians watching the sky, sending back slow, steady streams of data. Even those streams are less busy now. The telemetry graphs descend to peaceful, stable lines. Above Mars, 2 spacecraft continue their patient orbit. TGO drifts through the red twilight. MRO glides over ancient craters. Their sensors remain attentive, yet calm. No new anomalies. No unexpected flickers. Just the faint motion of dust and ice from 3I Atlas, glowing against a field of distant stars. And here on Earth, the night deepens. City lights soften. Windows go dark one by one across California, Texas, New York. Small towns settle. Highways empty. Millions of people breathe a little slower, unaware that a tiny interstellar snowball is making its quiet escape above them. Somewhere out there, a lone amateur astronomer still scans the sky, hoping to catch a final glimpse. Somewhere else, someone simply steps outside, out of habit, to look up and wonder. And here, where you are, in this moment, you're listening. Just listening, letting the world fall away a little. There is something comforting about that, because after everything we've explored, UN briefings, global drills, Mars observations, scientific debates, this is the truth beneath it all. No impact, no crisis, no alarm. 3I Atlas is safe. You are safe, and the world is calm. The planetary defense drill will continue quietly until January 27th, 2026. But it is a background hum now, a soft rhythm carried out by people who have chosen to keep watch while others rest. You don't have to think about it anymore. You don't have to keep any of the details in your mind unless you want to. Those who guard the sky will stay awake for you. The universe, after all, has seen countless comets come and go. To the cosmos, 3I Atlas is just another whisper of ice and dust, a spark from some ancient origin, wandering with no destination. But to us, it became a story, a reason to gather our attention, a moment to coordinate across continents, a reminder of how small and beautiful our world is, a chance to practice caring for one another on a planetary scale. You don't need to hold all of that now. Let it soften. Let it dissolve, like dust in the tail of a passing comet. You've followed the story from Earth to Mars, through telescopes and uncertainties, through curiosity and calm. You've listened to the facts, the wonder, the questions, the philosophies. You've held it all gently in your mind, and now you can let it go. Feel your breathing slow. Feel the weight leave your shoulders. Feel yourself settle into the softness of this moment. Imagine yourself lying on a small blue world, drifting through space, wrapped in a thin blanket of air, protected by people you will never meet, working in places you will never see. Imagine that somewhere, thousands of miles away, a scientist glances at one last graph, nods, and switches off a monitor. Imagine that they do so with the quiet knowledge that everything is peaceful tonight. Imagine Mars glowing faintly in the distance. Imagine 3I Atlas shrinking into a single spark. Imagine the infinite night stretching out around it, silent, gentle, ancient. And imagine yourself floating there with it, weightless, unburdened, supported by a universe that is larger than every worry you've carried today. Because you are safe, the world is calm, and the universe is quiet tonight. Let those words drift through you like stardust. You are safe. The universe is quiet tonight. You are safe. The universe is quiet tonight. And if some faraway comet is beginning its journey in another corner of the galaxy, it will be a story for another time. Not tonight, not here, not in this moment of deep stillness. Carl Sagan once wrote, "Somewhere, something incredible is waiting to be known." He was right. The universe is full of wonder, but wonder doesn't require wakefulness. It will wait patiently until morning. For tonight, you have learned enough. The rest can wait. You are safe. The universe is quiet tonight. Good night, traveler.